going to try to do a step by step through how to hook up the Rogowski coil to the integrator to the oscilloscope. And this is a Handtech oscilloscope I've been talking about. So basically, I guess, start off with, we have, here's our disconnect going to the drive. The drive, we have the output going down here, and I have these quick disconnects here, these twist lock connects. And then as you can see, this is unshielded cable going down, and I got about 10 foot, maybe 15 foot of cable, just kind of looped down around the back here and then going into the motor. Now this is a WEG CFW 500. I think it supports up to a 5 horsepower motor. And then this is a WEG 3 horsepower motor. So, basic setup you're going to see everywhere in the field. Alright, so number one, what we want to do. Again, we want to measure this without the shield or grounding. So what I've done here is I've separated the 4 wires. So you've got your 3 phases here, which are identified with the red, white, and black, and then the ground. We want to measure the common mode current with the Rogowski coil just around the 3 phases. As you can see here, the ground is outside of the Rogowski coil. Anything within this loop here, this is the Rogowski coil once again, anything in this by inductance will pick up whatever the currents are, and we can see it on the scope. So again, 3 phases, no ground or shielding. The other end of this coil goes to what we call the Rogowski coil integrator, and it's identified on there. It says the probe. Then the output of this integrator goes into our scope, and I just by choice chose channel number 1. We've got 2 channels on this particular scope. We connect that to input 1. This is the Handtech DS1200, which is a storage scope, good scope. And so what we're going to do now, now that we got the setup here, we're going to go through step by step how to set up the oscilloscope. So number 1, power on. Unfortunately, this scope, once you power it down, loses all the settings it has. So unfortunately, every time you turn this thing on, you have to go through these step by step. So here's the screen as startup. First thing we're going to do is we're going to go to channel 2. We're going to hit channel 2 button, and at the bottom here it says enable on or off. So we're going to hit that and turn off channel 2. Just don't want to see it in there. So now you got channel 1 at the very top. That's the yellow line indicated here. What I'm going to do is go down to these arrow keys here and push this down. And I'm going to get that line down here where we can see it a little better. Put it right in the middle. So just like that. And we got that line down pretty close to center. Alright. Now we set up the scope. So what we do is we want to, now this integrator here, this particular one has a 200 millivolt per amp. So we have to take that into consideration. What you see right now is it's measuring 1 volt per division. So 1 volt from here to here, that's 1 division. So we're going to set this down to 200 millivolts per division. And you do that by pressing these keys up and down. So here's 200 millivolts per division. As you see, the line didn't change. The second thing we want to do is the frequency. We want to set that frequency by using these buttons here, time per division. We're going to set it to start off around 20 microseconds. Let's start 20 microseconds. All right, so as you see, we've got 200 millivolts per division. That's the scale here to here. And the microseconds here, 20 microseconds, is from here to here. So each division that is 20 microseconds. And to get the time base, you just divide 1 by whatever you come up with. 1 divided by 20 microseconds would be. Alright, so we got that. Now, the other thing we want to do here real quick is we want to do what's called measure. So here's a button called measure. We push that, and it comes up. Alright, channel 1 is your source. You can see that glare on it. We want to measure voltage. And then we want to go, time's out on us here, so push that again, and we go to the next screen by pushing this. I'm sorry, we'll press this button, go to the next screen, and we want to measure maximum. So you push F3 is maximum. And as you can see, it automatically comes up and it says V max is equal to, it just fluctuates until it has some kind of input. It's just kind of floating around. So this is the basic setup. Then it goes back to the default screen. Okay? All right, next what we're going to do is we're going to set this motor. We're going to turn this motor on. I currently have it set at 30 hertz, so I'm just going to power that on. And as you can see, the motor is now started up. And the screen has this shot on. All right. Oh, one thing I forgot. You got to turn the integrator on. You've got this little power button right here, so just push that on. All right. So here's your basic screen. And every motor and every drive you see out there, if you got this set up correctly, if this is going through the 3 phases, you're going to see the same signal. Same exact signal. Just different amplitudes, different frequencies, but you're still going to see this noise. And each one of these peaks you see on here, each one of those spikes that you're seeing in there, is actually what's going through the bearings, going somewhere. As you can see here in the bottom left-hand corner, you got the V max, and that's fluctuating around. The problem with some of this stuff is you have to kind of watch it. You can't just set this for this particular scope and say, well, the maximum that was ever read out was 600 millivolts or whatever. You'll just have to kind of watch it. You kind of watch it for a little while. And as you can see, it's fluctuating anywhere from 400 and something up to 600 millivolts. Okay? Real simple. All right. So that's number 1. And then I'll tell you in a little bit, probably in a different message, but you'll read that measurement, divide that by the 200 millivolts that is built into this integrator, which says on the back here. Nope, it doesn't say that. Oh, and the screen keeps cutting off because it'll time out too, so just push any button and it'll come back on. Alright, so this Rogowski integrator itself is 200 millivolts per division. So you would take, and we saw the peak on it around 600 millivolts, you divide 600 millivolts by 0.2, and it gives you 3 amps of peak current. That's the peak current. We don't care about this dimension. We care about either here or here, whichever is the highest. And this is telling us what that highest one is, maximum. Again, we're set at V max. All right, so that's that point. All right, one thing too that I like to do, and you can freeze this too, by the way. There's a button down here called Run Stop. If you push that button, that screen will freeze on you. And you can look on here, you'll see 468 millivolts, and you'll see the peaks that's in there. And you can push that and start and stop many times and just keep doing that. And sometimes you can catch a good high peak in there, sometimes you can't. That's irregardless. You have to watch that peak there. Other thing I like to do is I like to adjust the frequency. Down here is time per division. If you remember, we set this at 20 microseconds. But what we want to do is we want to spread that out, because 2 functions of Coolblue and Nala is to not only reduce the amplitude of that current, but it's also to slow the current down. So let's spread this out. And we'll just spread it out, spread it out, spread it out until we get down. We're at 500 nanoseconds per division. That's exactly what we're seeing there. Okay, we'll set it back to 1 microsecond per second. All right. So we're going to push this start, stop again. And you'll see that the time per division, you've got from here, from up to down, to back up to here. That's 1 cycle, or 1 frequency. And what I'll tell you to do later on too is I'll tell you how to interpret that. But basically, just pushing this run stop again, you can see that fluctuating a little bit, but not a whole lot. All right, so if we say 1 microsecond, 1 divided by 1 microsecond means this is a 1 megahertz signal. That's how high frequency it is. All right, so what we're going to do now is we're going to just leave this as is. And we're going to power down the drive. And it takes a little while for this to bleed down. And that fan on this particular WEG drive continues to run. It's a manufacturing type thing, but you don't want this thing to overheat, and they will overheat. So we'll give it about 10 seconds to power down. And then we're going to hit the disconnect, so we're powering the whole thing off. We'll continue to hear this thing running for about another 10 seconds, so it's best just to wait until that cuts off. It should be about right there. All right, so now I'm going to put the phone down for a second. But what I'm going to do is I'm going to disconnect this disconnect and insert now what I have set up here, a disconnect here, or a quick lock. I have a cool tube, that's for radiated emissions. Then I have two Cool Blue cores with the loop. So I run the wires through these cores twice. And then I have two NOLAs on each individual phase. And again, I have the ground outside of that whole assembly. And then here's the other end. All right, so what I'm going to do is I'm going to disconnect this. I'm going to connect this one. And the other end goes through here. Right, so now I have a quick lock there. I have the whole assembly going into the other end of this. Right. Now I'm going to put the Rogowski coil back on. Again, we're going to put it through just the three phases. Connect that back up. So, as you can see, three phases. Here's the cool tube. You know, here's the drive coming down. Ground is outside. Cool tube. NOLAs, Cool Blue, and going to the motor once again. All right. So we got the same setup as before, except for now we have the Cool Blue and NOLA set on it. What we're going to do now: power supply on. Takes the drive a couple seconds here to get ready. Get the scope and the auto shut off again. So there's the signal we had before, adding all the Cool Blue and NOLA. Now power on the motor. Motor spinning up. Integrator's on. Alright, so if you look at the signal, I've got it stopped where it was before, so it held that pattern. Now what we're going to do is we're going to hit run stop, and we'll get to see the difference. See the big difference there. Went from that squiggly 1 megahertz signal, you know, at a certain amplitude. I think we were measuring 500, 600 millivolts. And as you can see down here now, we're now measuring 100 millivolts. But you can see this current. The frequency slowed way down compared to what it was before. So we just did a run stop here and kind of look at that. All right. And again, you got about 100 millivolts down there. So we went from about 500, 600 millivolts, from about 3 amps down to about a half amp. That's good to change. All right, so now let's get it started back up. Now let's adjust the frequency out, go back to where we were before at, there's 20 microseconds. Big difference in the peak amplitude. Again, we're seeing up to maybe 200 millivolts there, a little over 240, something like that. So we went from about 6 down to 240. So we're seeing about a 65% reduction. Again, that's good from, this is for radiated emission. We're not going to count that in the sightings here because that's in megahertz well above. So here's Cool Blue, there's NOLA, disconnect load, and there's our signal. And we can freeze that, and then just keep freezing, starting, freezing, starting. And that's pretty much all you do for testing Cool Blue and NOLA. So we'll shut this back down and I'll make some comments and put that in the letter. But here it is, that's it.